Hello, welcome back. This is an alternate video for episode 31 where I worked pretty hard on target practice. So this can perhaps be a thing I do if a session goes over, I don't know, like an hour 15 or something. I'll just do a quick little summary of what I did and give you kind of the abbreviated version if you don't have time for the full thing. So anyway, Enzo Capretti here wants me to work on, anyway, that's the new equipment. Non-lethal devices work. They don't fire like conventional weapons. So Avalon City has some kind of security force who's using new weapons that they're having trouble using, so they want a firing range. And I'm going to build it for them. Oh, right, that's my victory message there. Okay, so what happened here was I took about 4 hours to figure out how to deal with all this stuff. I think my copy was the good one that worked. Yeah, right, so that has that. Detect is a simple input that detects that a trainee has fired their weapon. Target X and target Y are simple inputs that detect where the target has been hit. Score 1, score 2 are X-bus outputs connected to large numeric displays. They're here. 2 trainees take 4 shots and score points depending on where they hit the target. To determine the point value of a shot, find the Euclidean distance using the Pythagorean theorem between the hit location and the center of the target, located at 50-50. So yeah, as soon as I read this, I thought, dude, do I have to implement a square root in this language? But eventually I figured out, no, I don't. I just have a bunch of thresholds, so I can just work with squared distance the whole time. Numeric displays should be updated with the trainees' scores as they compete, and should flash 3 times at the end before turning off to indicate that the game is over. There's a lot packed into this spec. Like, this is an incredibly complicated device, and it took a huge amount of effort to pack all this working into just this much space. I have no room for anything else. So every time so overall way that this operates is every time detect has a pulse on it, I need to do some logic to figure out where the target was hit, assign a point value to one of 2 players, and then display that point value. Things that make this hard. The player IDs, so it's player 1 for the first 4 shots, player 2 for the shots 5 through 8. So I just have to count myself and know which player is which. So it's always player 1 4 shots, player 2 4 shots. The scoreboard has to flash 3 times and then turn off, just like this. These are X-bus outputs, so they have to continually have messages sent to them to display for the display to stay for that tick. I can't just set a simple input and leave it. It has to be pushed out every frame. So on a tick like this, I just do nothing. So that's how I flash. Then after this, the scores have to reset for the next round. Resetting was one of the latest things in fact, it was the last thing that I got working. So when I tried to solve this, I started by detecting a shot and figuring out the point value. So that was the start. That's all this logic. And everything over here is for display and resetting. So since there are 3 simple inputs and I wanted to reduce this to 1 microcontroller, I used a DX300 to transform the detect value, since that's the only one that's just 0 and 100, to an X-bus pin. So that's all this DX300 does. The 2 simple inputs just go to the simple pins on this MX6000. So first I check in DX300 numbers if detect has gone off, because this has to run every tick to do stuff. If it has not, I just wait. When waiting, I don't just sleep. It's actually a lot more complicated than that. Originally I just waited, but because there is display logic here, this thing, the very end, is what actually displays things. It needs to receive a message whenever the game is in progress to output stuff. And this needs to know how many ticks to sleep because it needs to go to sleep for a longer time when flash is happening, because that involves these just going off and processing things on their own. without checking detection and stuff. So the game is just disabled here. If you shoot while the scoreboard is flashing, nothing will happen. And I think that's perfectly reasonable. So anyway, the wait command is a little more complicated than that. But anyway, if detect has happened... right, so AC is counting shots. If it's counted to 4, then we're player 1. If it hasn't counted to 4 yet, then we're player 0. So whichever player it is moves to X2, this one. And I'm going to process the shot and distance and point values and stuff here. So first, player ID comes over the line, and then shot coordinates. So target X, target Y. So those are 0 to 100 values. 50, 50 is the center. Then I count because a shot has happened. Then I see if I've counted to 8, and the game is over. I reset my shot count, and okay, this happens regardless. So if a shot's been detected, I move a bunch of parameters to X2, basically doing a function call here with player ID, X, and then Y. Then I take the results and move it to null. This is important for synchronization. I'll explain why in a bit. And if I had been on 8, I want this to happen regardless after... It doesn't have to be after that. I could totally put this here. It would not make a difference. However, I could not put this here because it is important that I move the X2 to null before the -1 goes out to X3. So my X2 line goes in here, does a bunch of stuff with these 3 and potentially the 100p14, then comes back to me. So all these functions return, then I go on to the next phase of the program by moving either my shot count or a -1 and then my shot count out to X3. So it's either going to get a -1 and then some junk it'll ignore, or a value that it's going to actually use. I forget how it actually uses this value. We'll find out. So before I worry about output, let's look at these things. So X2 here, the X2 of this receives target coordinates and converts them into, I believe, a distance value. So anyway, distance formula. For an arbitrary number of dimensions, x squared plus y squared plus z squared plus w squared plus, it doesn't matter. We're only working in 2 dimensions here, but it doesn't matter how many. It's just component squared plus list of all the other components squared. And since I'm doing squared values here, the 999 to -999 limit very much comes into play. It just so happens that the distance thresholds here are just such that it fits exactly in Changcheng micro integer space. So within the just under 2000 number space, I can square anything from... I can square 30 and get 900 and not be out of range. So if distance is greater than 30, you get -2 points. That's this zone out here. If distance is between 20 and 30, you get 1 point. If distance is between 10 and 20, you get 2 points. If it's a bullseye, if distance is less than 10... Yeah, if distance is less than 10, you get 4 points. So that's how the scoring works. And yeah, distance formula just gives me, for any point on here, a number representing exactly how far that is away, so that like this point is the same distance as this point, even though the y coordinate's a little less, x is a little more, well, a little less since it's negative. Anyway, so what needs to happen for that is, yeah, basically this controller does this, x times x plus y times y. So it waits for input from its x0, which this gives first as the player ID. It moves that player ID into its DAT register, shuffles it on to its X1 line, which is the dude that talks to my 100p14. This is where the score values are stored. So we'll worry about that in a bit. It also shuffles it over here, because I had to repeat that value. So right, the task that needs to happen here before I go to the output logic is to update this. You know, this is kind of a master data store of what the scores are. I have to update that with current score values, which means whichever player is going, their score needs to have a point value added to it, and then stored again back in that same cell. So player ID is the address of the cell. Player 1's here, player 2's here. And that's what I'm shuffling around. So I put it once here, where this sets the address for the read, and then I put it over here and repeat it, just because that was the most convenient way to do it. That's the address for the write. So read address goes here, write address goes here to subsequently go here. So while that's happening, I read the x value, I subtract 50 because it's 0 to 100, I need it to be negative 50 to positive 50 to get into this coordinate space. I square it, multiply by itself, and then I squirrel it away in dat. I was using dat briefly for what came in from here. I could use ac for this, it wouldn't make a difference. Yeah, so it would be exactly the same thing if I did this. It makes no difference at all. Huh, one undo undoes all those. How about that? Anyway, so yeah, I have squared x in dat. So that's this part of this this equation. An equation requires an equal sign. This is just an expression. There we go. That's the E word I wanted. Anyway, so that's there in dat. Like I'm doing a save instruction in TIS 100. I miss that language. I liked it better than this one. This one's fine, but I like TIS 100 language better. Then I take the Y value. It actually doesn't matter which order these come in. Plus is commutative, so I could do Y times Y plus X times X, and it's the same. But I'm doing X plus Y. So move X0 sub 50, mul ac, and add dat. So that sums the two together. That does this part of that. And I have this entire value in my ac register. I move it to X3. And then I take your return value and put it out here. Right, so this is for the purpose of synchronization. You need to know when you've done your job. So that's what this last line is. Anyway, so this processes raw inputs and sends them on to the appropriate place. This takes the location vector and turns it into a squared value. So one scalar goes on to this processor here. It'd be nice if I could like name these things, but I don't know, I can just keep track of them spatially. So select x1, move x1 dat. So I read the squared, the result of this expression into the dat register here. No, I don't. I read the player ID. I read the result of this expression to the ac register. Then I just do a bunch of thresholds. If it's less than 100, which is 10 times 10, distance less than 10 is less than squared 100, then 4 points are awarded. That goes to your x2, which is this controller. So 4 points, and then I'm done. If it's not less than 100, but is less than 400, 20 times 20, 2 points, then I move 2. If it's less than 900, 30 times 30, 1 point, then it's 1 point. Otherwise, it's minus 2 points because it's out of range. So anything above 900, or 900 itself, is considered a miss. There's also like an actual miss. Like the Trainee 2's second shot doesn't even hit the target, so it doesn't get a... Well, maybe it hits it exactly here. That's possible. Almost on the scoreboard. Man, for a shooting range... Well, I guess... I was gonna say you really don't want your scoreboard directly on the target you're shooting at, but... I guess this thing has to be impervious to whatever this weaponry is. These are supposed to be non-lethal weapons. Yeah, so they're not firing like full velocity bullets or anything. Okay, so whatever they're shooting won't destroy this and can just be detected by it. Anyway, that's not part of the puzzle. I'm just making up stuff about this world. Anyway, so right. Forward raw input to the appropriate place, turn into a distance value, turn into a point value, and then you need to actually store it. Like, this all ends up being perfectly elegant, with a slight little mess for forwarding some messages to wait for this to complete. The real mess is over here. So anyway, I take the first player index that I get, the one I get from here, that goes to x1, and I move it to x3, the address line. So go to this address. You know, we could actually do this while describing it. Yeah, let's do that. Should have been doing it all along. Well, I'll finish describing this at least. Then we'll see it in action. x2. Okay, so read the value that's already there. Add the incoming point value from x0, the one that this sends in these 4 places. And then take the squirreled away repeat of the player ID, which was stored there and then moved out here, and write it again to the address line. This ended up being easier than, well, I don't know. It just ended up being the most sensible way to do it, because this needs both of its registers to evaluate this expression. This had a spare register that it could just use for dat. I guess what I could do... Hey, I could save some lines here. Check it out. I can optimize this slightly. I'll make another copy. Copy. I can actually just move x0 to x3 here. This is a terrible idea. Well, I have a copy, so if this doesn't work, I can... Oh no, it doesn't work, because... No, it's fine. Let's see. Move dat x2. I think I'm saving 1 line by doing this. Oh, so that would mean this would not even talk to... Yeah. I also saved some wire. No, I don't, because you need the result of that. Never mind. That's fine. Okay, so this wire now only goes in this direction. Wire doesn't cost anything, though. So you're actually going to SLX on x0 this time. Move x0, x3. So yeah, by doing this, I save 2 lines here, and I put 1 extra line here, and I had an extra line. So I move that to dat, I move dat here, and it just makes more sense to have this doing both the repetitions of the player ID. So this invokes the function, but the return value comes to here. It's fine, it makes sense. Alright, so everything should work there. Right, anyway, so add that value, move that again to the address line, and write the added value to it. And then I move a 0. Okay, so this isn't actually return value. I don't need a value, I just need some junk that goes here and tells you to wake back up, because it blocks on that IO line. So anyway, that's the job those do. Then once all of that has completed, it tells this part of the program to do something. So x3 comes out here, goes to this x0. What's your job? Move x0 ac, tech ac -1. Right, so if you've gotten the -1, that's my end signal. Right, so I've counted to 8. Then I do a lot of complicated stuff, but if this is just a normal message, I move 1 to x0, which is... Right, it tells this how long to sleep. Yeah, this gets a value back for how much to sleep, so it's important to sleep a different amount depending on what this tells it. I test if I've gotten a 0. Why do I care? Interesting, so I test if I've gotten a 0, only if I... that. There was something about this particular minus that I am having trouble remembering. I mean, it's good for efficiency. You don't need to test if it's 0 if I know it's -1. So anyway, if it's not 0, then I move 0 to x2. What does that even mean? Right, because I do the add 1. Yeah, the only time this ever gets a 0 is if... Ah, okay, so that's actually how I discard this value. Because of the line constraints here, I did have to move 2 values over here. I had to keep on moving the number that I counted to. Why the heck do I do this? Oh, dude, I can save more lines. Okay. I have 0 reason to do this, because 0 is my signal. Huh. There we go. I think that makes sense. Yeah, I don't need a special marker value because 0 is the special marker value, because this will never complete a detection phase and send 0 unless it is the last one. And that was what the -1 marker was for. Well, cool. All right, so my line count's going to be better, and my power will be slightly better too. Cost will be the same. Or maybe I broke it. I have copy for that. 5x2. Right, okay. So if I've gotten a 0, then that's my end of thingy marker. Take x0. Oh, check it out. I can do even better. Tick x0, 0. Neat. This is nice. Man, I thought I had no space, but look how much I just freed up. That's nice. Move 5x2, move x0, null. Right, and this is no longer necessary because I'm only moving the 1. Yeah, because it would send the -1, then send another 0 and wake up, and all of that code was just to ignore that extra 0. Wow! Look how this compacted. That's kinda surprising. So x2 gets a 5 and x0 gets an 8. That's the number of ticks to sleep. So if it's the end, you sleep for 8 ticks because of flashing. You need to stay asleep for that long. I wonder if I could jack this value up at all and save some... 1, 2, 3, 4, 5, 6, 7, 8. No, I think 8 is correct. If they take another shot soon enough after that. Move 1, x0. Oh, hey! I just realized my graphs were very much the average there, very much average there, a little high on line count. So maybe I'm fixing this line to be here right now. Neat. Okay, anyway, so move 1, x0, and 0, x2. So anyway, I want these in that order, just so it's the same. So I tell x2 to do stuff, and then I tell x0 to sleep. Okay, so x2, depending on whether you are displaying... Oh, I hope this works. Yeah, it should. Oh, no, I can't do this. Can I? Hold on. What did this do before on 0? Nothing. It did nothing. Yeah, it never did anything on 0. No, this is fine. This is fine. This is fine. This makes sense. Yeah, of course. 0 can never come in unless it's the end. Yeah. Right, so by the way, every tick... Oh, no, it did need to literally do nothing on 0. Yeah, that's a problem. I can't do this because there are actually 3 different actions this takes. Okay, I can save some lines, but not that many. Right? No, I don't know. I'm going to put this back how it was. I saved a line here. Maybe that'll be enough to get the graph. Okay, so there are actually 3 different actions this takes. It's either display nothing, that's what 0 is, display something, the something that's stored in here, or do your ending flash action and reset. So when 0 comes in here, it needs to actually do nothing, and 0 will be coming in because my wait moves a thing to this. Because this needs to do something every tick. I had this problem, I much more clearly understood it now, where if I need to do something every tick and sometimes get an XBus message, that's actually impossible, because I don't have an instruction to check for I/O on an XBus line. I can only SLX. So this SLX never waits a full tick, it just waits until this has gone through this part of its program. But this will always wake up every tick on that. Oh. So then, I don't need the SLX. Neat. Because it never sleeps. It sleeps 1. So that doesn't save a line. Never mind. Yeah, this is the same as a sleep 1 at the end. That's fine. Oh wait, no, it does something different, because when I tell this to sleep 8, then that stops doing anything here. Anyway, so the whole idea is this does one of 3 things. Display nothing, display whatever's in there, or do its ending action. And what's communicated to this determines that. If nothing is communicated, if this is actually 0, then this does nothing, displays nothing, and the thing stays blank. So, if I move a 0 to x2, over here, this thing wakes up. It takes that value and moves the address 0, moves 0 to the address line here, because I just want to display this value to score 1 and this value to score 2. So this one sets the address line, this one down here reads it and outputs with it. Move 0x2, so 0 is the message that tells it to display something. And then nothing happens with this because ACK is 0. So that falls through to nothing. I'll explain what the other case is when I go over the ending logic. So display logic waits to get a message. Takes what that message is and puts it in its register. And right, because there are 2 different things this can do. This can either display or reset. So it gets... How the heck does the flash work? Oh, it's here. Right, this logic I didn't go through yet. So if I'm displaying, I just move x0, connected to the data line to x1, move x0, connected to the data line to x2. So read this value, put it there, read this value, put it there. So just automatically move the address pointer around. And again, this manages the address pointer with this instruction. There it is. And then all of these are minused out, so none of those execute. So that displays. If it is at the end, again, so this is going to move 8 back here, tell it to just go to sleep while I do my thing over here. Because no new values are coming in, I'm just using the existing ones to... Right, okay, so the whole thing about how I can't sometimes listen to XBus and also do something every tick, so this is just doing something every tick, always getting an XBus message, and using this as a buffer to for communicating between the 2 sides. So anyway, so when the game is over, this detects that and it tells this with a -1. I move 5 to x2 instead of 0. I probably should have been running the program the whole time while I was doing this. It'd make more sense, but don't worry about it. I'll do that right after this. I discard the 0 that's coming in, because it doesn't mean anything at this point, and move 8x0. Yeah, right, so that's that, tell it to sleep. Okay, so anyway, this gets a 5 instead of a 0. So it goes into the disp loop as before, but this turns into an actual loop that if the value is greater than 0, TCP ACK 0, right, if it's greater than 0, I subtract 2 and sleep 2. So I'm overloading the ACK value such that I have a loop here that doesn't loop at all if I've gotten 0. It just goes through one iteration. But if it gets an odd-numbered value greater than 0, I can actually detect. This is how this controller detects when an end has happened, because otherwise it just doesn't know anything about it. It's just told, hey, go display something. So anyway, sub 2, sleep 2. The sleep 2 means it lets a tick go by with no output going here, so that's what flashes. Then it redisplays what it has, and keeps looping until it passes 0. So right, if exactly 0 comes in, this happens once and doesn't do the ending action. But this goes to -1, because 5, 3, 1, -1, subtracting 2 each time, goes to this instruction, which moves 14 to x2. So you get either a 0 or a 14. 0 means display your stuff. 14 means write 0 to this 14 times. That was the only way I could fit a clear out command for this buffer, because I have to reset this when the game is over, back to 0. So take x0. If not, then move 0 to x0. Right, the data line. So I write a 0. I subtract 1 from ACK. I test if I'm done, and if I'm not, I keep on writing zeros until I've gotten all the way through all 14. So let's run it. On a tick where nothing is happening, this jumps to wait, it moves its 0, so 0 shots have been fired. Over to x3, 0 shots have been fired, so it is not equal to -1. This is told to sleep for 1 tick. It is not equal to... Oh yeah, that's the other problem with what I was doing. Well, no it's not. Not exactly. It's complicated. Right, and it is 0, so it doesn't do that line. And the tick is done. Okay. So when detect happens, less than 4 shots have been fired, so its player ID is 0, and that goes out to x2. So that's your first parameter. It goes here, right, because I changed that. I've saved 1 line. You squirrel it away and send it to this, waking that up. You want to read the target X value. A lot of things will be happening at the same time here. So 0 goes out here and wakes this up and is going to be written to the address. All the while this is doing some arithmetic to get the squared value of those. 441 is that one. This is waiting for input on its x1 line, so it waits for this. Everybody's waiting now. You got past this, so you're going to count 1 shot has been fired. This is still doing arithmetic. This has set the address at that point and read the value. The value is 0. Player 1 has 0 points. And now I want to know how many to add. I've not counted to 8 shots yet, so that just waits for that to complete. Okay, so this is going to block until this process is done. So add this squared value to this squared value, and you get 970. Somewhere out in this region. Oh hey, I actually see the shot. There it is. I didn't actually notice that when I was running this before. So you see where they landed. Right, and that value goes here. You're going to do the threshold stuff. It is not a bullseye. It's not a 2-pointer. It's not a 1-pointer. It's a -2. So -2 goes here. Gets added to that 0, so -2 is player 1's score right now. Whoa! Did I hit the wrong thing? I think I did. Hotkey for this is E. E to step once. Move X0, X3. Right, address line. So the repeated address goes here. I'm writing to address 0. Move dat X2, 0. There we go. Did it happen? It took a tick. And then the -2 score gets written to that location. Great. And then move 0 to X1. So that's the I'm done message. That's the I'm done message. Gets discarded, and then this is told, one shot has been fired. Do your thing. So one shot has been fired. It's not -1. Sleep for 1 tick. Alright, so you go to sleep, you're done for this tick. It is not 0, so I do want to display something. 0 goes out here. 0 is there. Alright, so I'm going to display. You go to this address on this with this pointer. You're going to display with that. And this is going to do nothing. Move X3, ACK. X3 is that incoming value. It is 0. So I read the -2, put it to score 1. There we go. Read the 0, put it to score 2. And there we go. Everybody is asleep. There we go. Time unit goes by, -2, 0. Alright, so, wait, hang on. So let's look at one of these time units. So, detect didn't go off, but I have counted more than 0 shots. So I do tell you to display. So this is exactly the same minus doing all this process. That goes through the same display logic we just looked at. All of that stuff goes out to those. Alright, so another shot comes in. Same stuff happens, arithmetic. So the final value is 773. That sounds like a 1 pointer. It's here, yes. Okay, and I can actually see it there. Neat. TLTAC 100, nope. TLTAC 400, nope. TLTAC 900, yes. 1 point. Here you go. Add that to the -2 that you read out of there. Write it to the thing. Tell this it's done, and then go display it. So that's great. That all works exactly as you'd expect. So then once 4 shots have been fired, when we detect this one, this gets a 1 out here instead of a 0, which goes there. Okay, that turned into 1. So now that's going to be the address that this is read from and written to. Player 2 got 1 point for shooting here, I guess. And yeah, same stuff. It reads both, it displays both. Everything is as expected. So that's where all the shots are. Oh shoot, I skipped the important time unit. Okay, let's do that again. D to advance that. Okay, so detect went off. More than 4 shots have been shot, so this is player 2, or player index 1's thing. Do all the arithmetic. However, ACK is equal to 8, so 8 shots total have been detected. So I'm going to reset it and wait for that to complete. It completed, and here you get a -1. So ACK equals -1. I'm going to move that 5 over there to do the flash display. Discard this 0 that's coming in that was unavoidable because I had line count constraints. I did have to discard that junk value. And then tell you to sleep for 8 ticks. So while that's happening, we're doing 1 display loop, and then we're doing some more. Sub 2, that's now 3, sleep 2, so that's going to wait all the way until there and do nothing. Reset the address, tell this to display, check if I'm done, I'm not, subtract 2 more, sleep 2 more, display again, do that stuff, check if I'm done, not yet, subtract 2 more, display 2 more. Okay. tell it to display, then check if I'm done, because I do display the final time before shutting off. Alright, so this is done, now it's moving 14 to this. As soon as this puts that display out, it's going to go back to the SLX, wake up again right away, move that number of times to right to this. Can I decrease this by 1? No, I need exactly 14. Move x0 to x, and move 0 to x0 that many times. So write that value a whole bunch of times. 5, 4, 3, 2, 1. 0 goes there, sub 1 equals 0, and we're done. And that's that last time unit. Okay. And this is still sleeping for one more tick. And there we go. It resets just at the appropriate time. And that's how that works. Alright, so I saved one line. It looked like I could save more here, but then I realized I need actually 3 cases here instead of just the 2. So I improved this very slightly, and it wasn't enough to get to this peak. So somehow a conventional solution exists that uses fewer lines but does roughly the same on everything else. Alright, so yeah, I honestly don't know how you would do better on any of these, because like I was so crunched for everything. I don't know how I'd get my cost down. I don't know how I'd use less power. I don't know how I'd use fewer lines. This is the design, how it had to be. They're working great, and we're already seeing improvements in accuracy. Numbers for you soon. Thanks for sorting that one out. Okay, and that's how this works. Even summarizing it takes a long time. Alright, well, anyway, so that's done. I'll try and do these summaries for anything that goes over a certain amount, giving you even more to watch. Maybe this will backfire a bit. I don't know. We'll see. I'll just play it by ear. See you next time for this stuff.